There we go. So much fun when they reset all my technology over break. I love it so much.
Does it not work?
It works. It's back. It was just I didn't have the screen record option until just now. So now I can record it. Yay. Everything we're doing today is review. Everything. Everything we're doing is review today. Okay, because we need to remember how to do all the things. So we're going to do a few review problems, and then I have some, we have a review for the quiz so that we have it. So everything we're doing today is to get ready. We're doing the quiz for tomorrow over vectors.
Yeah, I told you in the morning.
Okay. So we're going to practice all of the things we need. Okay. So everything we've already talked about at least one time. So our kind of three main vocab words, at least for the beginning right here, we've got our magnitude, which is kind of our distance, change, the speed. The scalar, which is something that's defined only by its magnitude, so something that's only defined by like a distance or a speed. And the vector has both magnitude and direction, so vectors include the direction. So we're going to look at this list. I did not print these out. If there's any that like really hit for you, just write them down. And we're going to decide if it's a vector, if it's a scalar, or if it's neither. So vectors have magnitude and direction. Scalars have just magnitude. We don't have anything that's just direction. Like that's nothing. So if we have a boat that is 5 miles away, is that a scalar value, a vector, or nothing? Scalar. So that has a magnitude. What about if there's a boat 5 miles to the east? Vector. What if we just have a boat to the east? Neither. Direction is not just like a thing that makes a thing. It's just in the east. It's yonder. What if we have wind that's blowing 30 miles an hour? Scalar. What if we have a baseball that's thrown at 85 miles an hour? Scalar. Doesn't matter what it is. It's doing a thing. What if we have a ball that is thrown straight up at 5 miles per hour? Vector. That has a direction on it. What about a deer running 15 meters per second to the north? Vector. I was going to say, there may be some like that on there. Say it again. Just magnitude would be neither. Or just magnitude is scalar. Scalars only use the magnitude. It's just magnitude is something we're able to calculate later on, so I decided to do its own separate word. Because we calculate the magnitude, that's when we have like the double line thing where we get our vector here. This guy, that is the magnitude. So sometimes we calculate the magnitude, sometimes it's just involved in this piece. Okay, so questions on our scalar vector neither? Okay. So our vector operations. So we give you a couple of vectors. I've got A here and we've got B. So vector A, we've got this component form of 2, 5. And vector B, we've got this component form of negative 3, 1. So this is called our scalar multiplication. 2A. What do we do to figure out what twice vector A would be? Yeah, we're going to take this number up front, that's our scalar, and we're going to multiply the 2 times each of these pieces. So times this 2, and we're going to take our 2 that's in front times the 5. So our vector that we get here is going to be 4, 10. So the next one combines those two both together. We need 3A and 2B. So what's vector 3A going to be? 6, 15. What is vector 2B? Negative 6, 2. Yeah, because we add the x pieces together. So 6 plus -6 gives us 0. And we add our y pieces together. 15 plus 2, 17. So this combines together to make 0, 17. Similar vibe on the next one. Just be careful with our signs. What is a minus b?
-1, 4. Oh, wait.
Careful, 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 careful.
5.
Yeah, 5, 4. Because we have our 2 minus -3, which is going to give us 5. And our 5 minus 1, which gives us 4. Okay, so our vector operations. Right? So then let's remember all of our formula, you guys. Finding our component form, finding our magnitude, finding our direction. So I've written them up here, but again, I don't give them to you when it comes to the quizzes. So you have to know those. So first thing we need to have is our component form. We're given our first our 2 points. We're going to go from A to B. So we need to find how the x's change and how the y's change. How do we figure out how the x's are changing? Or how are the x's changing? Subtract. We're going to take our 7, the place where we end, minus where we started, -3. And then we're going to have our 2 minus the 3. So what is our component form for this vector here? We have our 4, we have -1. So this is going to become the component form of 4, -1. What that does is this takes this random vector that's off in space somewhere and it centers it at our origin. They all mean the same thing there. So you're finding the change in our x, finding the change in our y's. Now we're going to find our magnitude. That's what this guy is, with the double absolute value piece there. Our magnitude. And that's the one that's based off of the distance formula. So our magnitude of our vector here plus. What are we going to get? Square root of 17. Because we have the square root of our x that's been squared, which is 16, and our square root of -1 squared, which is 1. So we get square root of 17. So our magnitude is square root of 17. Cool. That's what this is for. It's for the questions. Because I know it's been like a week since we mathed. So we're going through it. I get it.
And that's his own answer, right?
Yep. Yeah, this gives us our magnitude. So this tells us basically how long the vector is. To figure out the angle, it's looking at something entirely different. We're looking at how far this is off from our x-axis. So to find our angle, that theta, that's when we're going to do our inverse tangent, arctangent, of our y over x. So y is -1, 4.
Do it in your head.
What is inverse tangent of -1/4?
Oh, we know this one.
No. No, we don't.
Negative, you might.
In a circle question?
She, you know,
Like when in doubt, check it out.
she's got mental brain loss.
It's on the unit circle.
Is it?
No. It could be pi over 4.
I was gonna say it would need to be in the ordered pairs, and so more than that, I was not. Okay. So we can type that in the calculator. like inverse tangent of negative 1/4.
Negative 14.
Mm-hmm. Negative 14.036. So we'll just go with 0.4 degrees. Just double checking real quick. What quadrant is this going to be in? 4, -1.
4.
Mm-hmm. What quadrant is this in?
4. 4.
Then we're in a good place. If this was in quadrant 2, we would need to be very intentional with this because we need to wind up in the correct quadrant. So this is a quadrant 4 and this is a quadrant 4, so we're good to go.
Right? We have
Okay.
pi?
If you're on radians, you add pi. If you're in degrees, you add 180.
Oh, okay.
Because we'd go around half a circle to get to the correct quadrant.
The one that said -1 or 4 is.
Okay.
Amateurs.
We are only going to do, we're going to do one more question.
Really?
Don't be mad.
How many questions? Oh, word problem.
I know. These ones are irksome and annoying and frustrating and gross. They are a thing, but they're not pleasant. This is one of the ones, if you still have like the little slips, it is one of the ones that we didn't do on the little things. But it's also only like the only one of these we're doing. So we've got a charter boat that leaves port heading north 60 degrees east for 25 miles. Nautical miles is not really different than land miles, but they're all special because they're boats. Nautica is a fashion brand, I think. Nautical just means on the water. It's boat miles versus land miles because boat people are extra. All right, and then the captain changes course going straight north. Due north just means north, pure north for 10 miles. So, what we have is we have port. Let's put port down here. And they go north 60 degrees east. So typically, like it's based off of where we started. Remember how we're gonna never eat soggy waffles. And north 60 to the east is this way. So this is our 60 degrees here. And they go for 25 miles. I'm just putting it there while we have it. Nautical miles. Because they're being extra. So here, captain goes, all right, we're changing. Storm ahead, we gotta move. So from here, they go straight north. Due north. For 10 more miles, they went straight north. And what we're asked to figure out is how far they are here. We want to know the distance, so we need to know the magnitude here. So we want our magnitude. And we want our angle, so we're also finding our theta. That means I need to have my vectors. I need a green vector, I need a blue vector. Yes, dear.
In the triangle, can't you like subtract 90? I mean, subtract 60 from 90.
I was going to say, if we did that and we looked at this angle here being 30, only problem that is here we have angle side side. And that's one of those things that it doesn't limit us enough. So we've really got to use our like love cosine stuff. and our vector stuff. Because we need that magnitude anyway.
How do you know we're supposed to find like data rules?
Because they ask for our direction and its distance. So the distance means I need the magnitude. For the direction, I need this angle here so that we can figure out where it's going. So because of the question. So when we are writing our vectors for this, what are we going to do? We're going to write one for green, we're going to write one for blue, so we can add them together. Getting to my actual piece here. So if I want to write a vector for the green piece, if we put it into our component form where we have our magnitude, which is 25, then we do cosine for our x's. What angle are we going to use?
30.
Why 30?
I don't know.
How are we sure that's like a 30-degree angle though?
Because we do.
No.
I was going to say, because it's not that one. It's
Oh, the other one.
that guy.
Oh, 30. Right.
Oh,
Yes.
Yeah, yeah, yeah.
So it's always based off of our x-axis here. That's the piece we're based off. So this 30 is the piece we need in our vector. And just like in unit circle values, cosine is the x, sine is the y. And those are some values we actually do know a little bit about. So we could write that differently if we wanted to. What if we wanted to write a vector for the blue piece here?
90, right?
Mm-hmm. Our angle is this guy. So we're going to have our angle as our 90 degrees.
And
Yeah.
And our 10 sine of 90. Then to get our combined vector for both pieces, we add them together. Yeah. I'm just going to kind of simplify as we go because we're going to have 25 cosine of 30. What is cosine of 30? Square root of 3 over 2. What is cosine of 90? 0. So if we have 25 root 3 over 2 plus 10 times 0.
Are we gonna get calculators?
Yeah, they're just over there. They just got put away over break.
I'm just gonna create a
That's
calculator.
0.
We all have to do one.
And we've got our 25 sine of 30. What's sine of 30?
Wait, 1/2.
1/2.
So it's 1.5.
Mm-hmm. And then we've got 10 sine of 90. What's sine of 90?
1.
1. So plus 10. Because sine of 90 is 1. And we're adding these two pieces together to get this black vector here. So we took this guy plus this guy. That gave us this. We took this guy plus this guy, and that gave us this. 10 times 1, which is the 10. That's where the 1 went.
No.
She doesn't get.
What was sine of 90 again?
1.
What's 10 times 1?
Oh, I see.
There we go. Yeah. It's like, sometimes I gotta ask you all the silly questions, and that's okay. That's what I'm here for. All right. We're cooking now. Now all we gotta do is find our magnitude and our angle, and then we're done. We've already done magnitude and angle once, so same vibe. Magnitude, that's the one that's our distance formula kind of guy. So that's when we're gonna take our square root of that thing squared. We got calculators. 25 times root 3 over 2, or you can do 12.5 times root 3 squared, plus our 25 times 1/2 plus 10, also known as 22.5. If you want to simplify it, that's fine. If you want to put it in as 25 times 1/2 plus 10 squared, that's fine. Just double checking.
No, okay. This is the last one, right? 975. Root square root of 975. Yeah, the name.
Oh, maybe. But I was going to say, I don't know that.
Root of 975. So 31.22?
There we go.
Okay.
I was going to be like, we are way too high. They went 25 miles and 10 miles. They did not wind up 300 miles away.
31.2.
Yeah, 31.225, 31.23, however it is that we round. 31.23 nautical miles. If you just put miles, I am 100% cool with that because boats are weird.
That's wrong.
So that's our magnitude. Now we're going to find our angle so that we can figure out what direction it is. I know. I'm going to do our angle up to the, I'm running out of space and colors. There we go. I'm going to do our angle up here.
Oh, but we already got that side, right? The one that the black line. That's
We've got its distance. Its distance is 31.23 miles.
okay.
But to find that angle, like we're already in vector land. We already have all the values we need. Let's do arctangent of our y, which was our 22 or 25 times 1/2 plus 10, also known as 22.5, over our hot mess, 25 times root 3 over 2, which you can straight up put in the calculator just like that. Just make sure that these are all parenthesesed off and you're good to go. Mm-hmm. 46 point, like 102, blah, 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 blah.
I got 1,000. Sarah is -4 feet tall. I don't know.
So 46.1 degrees. So that gives us that this angle here is 46.1 degrees.
Okay, so my calculator takes me.
Okay. So how would we put that as a bearing? If this guy is that theta. I'm going to move that a little further out. Oop.
Would it be like the same? Which angle is that?
Hang on, I'm redrawing it just because it was in front of all those other numbers. This is the angle that we got that was 46.1.
Why?
Why the number or why that location?
Why that location?
Because it's always based off of the x-axis whenever we do our inverse. Think like our unit circle. It always starts at 0 from the unit circle and goes from there.
Okay.
So if this is 46.1, how do we get our bearing? Yeah. Which I did weird. So that tells us that our bearing is going to be what? 43.9. Which direction? North. North, 43.9 east. Okay, so this is the angle we need to have for the bearing. This is the angle we get out of the inverse. Okay.
How many of these questions are on the quiz?
Not just
I hope it's
okay. Questions on this one? Because I know these are weird and annoying and kind of long. I was going to say, the calculations themselves are not difficult. It's the concepts that are more difficult to wrap around your brain around. So that's why I wanted to make sure we took some time and practiced it and came back to it, thought about it for a hot minute before I just threw you to the wolves. Okay? Questions on that one? I have a review here. I'm gonna pass them out. Okay? Pass them out right now. Yes, there's a review. Yes, there is a review. Yes, there's a review. Okay? So is that practice problems? Okay, you guys have the rest of the time to work on stuff. Ask questions. If you have questions on any of like the homework that we had, the practice homework or anything like that. Totally cool. We really only have one more section in this chapter, and then there's only one more chapter after this. So,
And she's laughing at you.
we have 33 more school days this year.
I'm so happy.
No, you're not.
Yes, I am.
Okay, so you're happy for 8 weekends too?
No.
33 more school days.
I have 5.
Yeah, wait till
I have like
You know what? It makes you feel better. I sucked in that class. I'm like, it makes it. Oh.
Oh.